We're on lesson 3 of chapter 11, which we're going to find probabilities using combinations. First, we're going to count combinations. Then we're going to use a combinations formula. Then we're going to find probability using combinations. So a combination is different from what we've worked with last lesson, which were permutations. A combination is a selection of objects in which the order is not important. In permutations, they were. Here's a situation where we would use combinations. You have 5 dinner guests to a party, and you have a table that seats 3. Which combinations of dinner guests do you want at the table? So in this situation, it wouldn't matter who sits in what seat. The only thing that would matter is that they sit together. For example, we could have this be a combination, or we could have these 3 be a combination in any order, or these 3 be a combination. And we're going to find out how to count them, use a formula, and then find probability with these. So it says count all the combinations of 2 letters from the list of A, B, C, and D. So often the best way to do this is to create a tree. So if we have the letter A, for example, and that combines with B to make a combination, C, and D, we just created 3 combinations. If we're looking for combinations with B then, I'm not actually going to put A down here because you notice I already have a combination of A and B. So this combination of B and A is the same exact thing, and we don't want to count that twice. But B and C haven't been together yet, and B and D haven't been. And then for C, I wouldn't do CA because that's already happened. I wouldn't do CB, so I would do CD. And if you notice a pattern, we found 3 for A, 2 for B, 1 for C. So for D, there's actually none. So how many combinations do we have? 1, 2, 3, 4, 5, 6. So we would say 6 combinations. So what we did just there was find combinations using a tree or just counting them out. It's not always going to be that simple to do that, especially when you have larger numbers like this problem here. When you get in these situations, it's sometimes just better to use a formula because it'll take you much less time and much less paper space. So the formula for combinations is this. It's the number of combinations of n objects taken r at a time, where r is less than n, and it's given by this. N combination r equals the factorial of n, we learned about factorials last lesson, over n minus r factorial times r factorial. Here's an example that'll hopefully make more sense. The number of combinations of 4 objects taken 2 at a time, kind of like the last one we just did, combinations of 2 letters from 4 objects, is given by this formula. 4 combination of 2, 4 factorial over 4 minus 2 factorial times 2 factorial, because 4 was the n and 2 is the r. So that gives me 4 times 3 times 2 times 1. And this gives me 2 times 1, 2 factorial, times another 2 factorial. This 2 factorial would cross off because they're exactly the same. And that leaves me with 4 times 3 on top, 2 times 1 on the bottom. 12 over 2 equals 6. And if you notice, we got 6 combinations last one too. So let's apply that to this situation. You order a sandwich at a restaurant. You can choose 2 side dishes from a list of 8. How many combinations of side dishes are possible? So 8 is a number of objects that you can choose from, and you can take 2 at a time. So 8 is n, r is 2. So let's write out our formula here. We would have 8 combination 2, and that would equal the factorial of 8. So we'd say 8 factorial over 8 minus 2 factorial. That would be 6 factorial times the r factorial, which would be 2 factorial. So if we write this one out here, we would say 8 times 7 times 6 factorial, and I'm actually going to stop there because I see there's a 6 factorial down here. So if we line that up, 6 factorial here times 2 times 1. So if we're going to cross off, these would cross each other off, so we'll just erase them. And that leaves us with 8 times 7 over 2 times 1. Well, 8 times 7 is 56. 2 times 1 is 2. 56 divided by 2 would be 28 combinations. So it's getting to the point where that was faster than actually drawing a tree with all 8 of these items. Now we could find probability using combinations. It says a yearbook editor has selected 14 photos, including one of you and one of your friend, to use in a collage for the yearbook. The photos are placed at random. There is room for 2 photos at the top of the page. What is the probability that your photo and your friend's photo are the 2 placed at the top of the page? We see this as a combination because it doesn't matter which one's on the left and which one's on the right. Well, if we use our formula here, remember the n is the number of objects taken and r is the amount that is in the combination group. Well, we see that there's 14 total objects to select from and there's 2 in the group. So we would say 14 combination of 2. And using the formula, we would have 14 factorial on the top over 14 minus 2, which would be 12 factorial, times the 2 factorial. So if we're going to write that out here, we would say 14 times 13 times 12 factorial, and that's where I'm going to stop because I see a 12 factorial down here to cancel out with that. So 12 factorial times the 2 times the 1. So these two would cancel each other out because they're both 12 factorial. 14 times 13 would equal 182. 2 times 1 equals 2. 182 over 2, that would give me 91. So that tells me how many total possible combinations of 2 pictures there could be on the top of that page. That's a whole lot of combinations, and you're only looking for one of them. So if you're doing theoretical probability, the total number of combinations is 91. The favorable one, the one that you and your friend, would only be one of them. So your probability would be a 1 out of 91 chance that you two would be placed together at the top.